And the purpose of this video is to help you understand your unit circle a little bit better and how to use it to your advantage as far as problems that you can do without a calculator. So again, your unit circle, remember, is a circle of radius 1. So just remember that every value on here will have a value of r equals 1. But the basic idea of using it is, once you decide on where your angle is, the unit circle has already worked out for you a 30, 60, 90 or a 45, 45, 90 triangle. It has the coordinates of the point on the circle corresponding to that reference angle. And again, those corresponding parts will help you as far as the sine. Remember that the sine on a unit circle, sine of theta, always corresponds to your y coordinate, and the cosine will correspond to your x coordinate. Tangent, again, is just a mix of those two things. Tangent of theta is always equal to y over x. So if we're doing something simple like the example up top, sine of 210 degrees, first thing we're going to do is go to 210 degrees. So again, 90, 180, around to 210, down in this quadrant here. And then, knowing that it's the sine, remember that sine, like we just said, is always going to correspond to the y coordinate. Well, the y coordinate given at 210 degrees, or 7 pi over 6 radians, is negative 1/2. So our answer, very simply, is a negative half. And problem is complete. Again, that comes from the fact that at negative 1/2, we draw that triangle in directly to that point on the circle. We're forming that right angle with that reference angle of 30 degrees, which means our sides would have been 1, 2, and square root of 3. But because our radius is 1, we needed to cut our hypotenuse in half, thus cutting all of the other sides in half as well. And because we went left and down, notice those side lengths now correspond to the coordinate point on the unit circle. And so we can use them as the adjacent and the opposite and find those sines and cosines very quickly and easily. So, using your unit circle, go ahead and try these 5. If you don't have a unit circle in front of you, you can always write down these 5 and then turn or reverse the video a little bit and pause it so that you can look at the unit circle that was on the previous page. Or you can always draw your own. Okay, the first 3 angles and trig functions of those angles are given up top. Notice that 135 degree angle, although technically going from the positive x-axis, is actually a 45 degree reference angle. If you started from here and went all the way around to 135, technically you're leaving a 45 degree triangle, which again with side lengths comes out to the coordinate point given below. The sine is always the y coordinate as it was on the previous example, and we've got root 2 over 2. The cosine at 5 pi over 3, well 5 pi over 3 again is down in the 4th quadrant. If we check our unit circle, the coordinate is given, and again cosine is always x, so we end up with our 1/2. And notice we went to the right. Cosine always goes to the adjacent, which will always be our x-axis. It corresponds to that x coordinate, which is positive down in quadrant 4. The tangent at 210 degrees, our coordinate point is given here, negative root 3 over 2, sorry it's a little bit mushed there, and negative 1/2. But remember that tangent is always y divided by x. So we're going to take our y coordinate, our negative 1/2, divide it by a negative root 3 over 2, therefore multiplying it by the reciprocal of negative root 3 over 2. Don't lose your negative there. And notice that the 2's are going to cancel, and you'll simply get negative 1 over root 3, which again has a little more work to it. A lot of times the tangents are going to take a little extra work as far as simplifying the fractions go. But if we rationalize the denominator, we can quickly find out that negative root 3 over 3 is a good answer. Alright, I'm going to pause the video again. If you haven't gotten done with the last 2, feel free to pause it as well, and I'll come back with the answers. Okay, looking at the sine of negative 5 pi over 6, remember that negative 5 pi over 6 means that we're going to go around the circle clockwise. Many of you may have found the 5 pi over 6 up in the 2nd quadrant. Another way to sort of figure out where negative 5 pi over 6 is to take that positive angle, taking you over into quadrant 2, and reflecting it over the x-axis. because that again will flip you directly down, or essentially take you clockwise rather than counterclockwise, and leave you down basically where 7 pi over 6 is. Another option would be to take negative 5 pi over 6 plus 2 pi. 2 pi in sixths, so remember 12 over 6 is 2, and negative 5 plus 12 will give you that 7 pi over 6. So if we look at that spot on our unit circle, coordinate is given down below, and remember that the sign again is always the y-coordinate, which means our answer will be 1/2. Now, sine of 600 degrees, kind of that same idea. We want to think about a coterminal angle. How could I go around the circle, much like we did with our radians over here on the left, in order to make it something we can look up? Well, 600 minus 360 is 240 degrees. And again, on our unit circle, that's a 60-degree angle down into the third quadrant, which means our short side, or our 1/2, is going to be going to the left, and our longer side, going downwards, is a √3 over 2. So if I look for the sine, again, that downwards angle is going to be our y-coordinate, and negative square root of 3 over 2 is a good answer. Now those were great things to look up because we could look up our triangles. But what if we're talking about quadrantal angles, or angles such as 3 pi over 2? When you draw, puts you directly on one of your axes. You can't draw a triangle in there because if we go straight to the x-axis, there's no reference angle. We have no width, no left or right. But remember that on your unit circle, we can call that coordinate 0, -1. And so using our ideas of sine of 3 pi over 2 being the y-coordinate on our unit circle, we can call that -1. Or if you remember, if we do y over r, remember that we're directly 1 unit downwards. So that same idea can be expanded to say, well, we are the y-coordinate divided by the x-coordinate, or again, still getting -1. Cosine of 3 pi over 2, again, goes to the x-coordinate, or x over r, and remember 0 over 1 basically just leaves you a 0. And the tangent, remember, of 3 pi over 2 is just going to be y over x, so -1 over 0, or an undefined value. If we do their reciprocals, again, you're just flipping over these fractions that we've come up with. So the cosecant of 3 pi over 2 is going to end up being equal to a -1 again. The secant, reciprocal of the cosine, well, now instead of 1 over 0, we're going to get 0 over 1. Sorry, 1 over 0. Instead of 0 over 1, we're going to get 1 over 0, which again is undefined. And finally, the cotangent at 3 pi over 2, well, instead of -1 over 0, we've got 0 over -1, or 0. And you'll tend to get sort of partnerships. We got 2 zeros in that set of 6, we got a couple of -1s, and we get a couple of undefines. You kind of get 2 of each for each of these quadrantal angles. Go ahead and try that at 0 radians, or if you think about it, really 0 degrees, same idea, putting a point on the x-axis and working those out. Okay, now we've got that all drawn out for you. Notice I didn't take the point directly from the unit circle. I went ahead and said, well, what if we made a circle of radius 5? And again, a point intersecting with that circle and intersecting the x-axis, then would be 5, 0, your radius being 5. Well, you'll notice that it doesn't really matter that the 5 is in there, because when you set up your ratios, 0 over 5 is still 0. The reciprocal of that would still be undefined. When you put 5 over 5, or the x-coordinate over the radius, again, 5 over 5 cancels down to 1, just like 1 over 1 would have, 100 over 100 would have. No matter what point you pick, those ratios are canceling down. And the reciprocal as well then is that 1. Remember I said there would be a pair of numbers. You got a couple of 1s. We got a couple of 0s as well. Sine of 0 is 0. Sine of tangent, or sorry, tangent of 0 is 0. Because 0 over 5, y over x, gives you 0. And again, the inverse, or the reciprocal, sorry, not inverse, but the reciprocal of the tangent, being the cotangent, will be 5 over 0, or our second undefined function. So that's how you can work those quadrantal angles. This last page is just a little bit of a challenge for you, a couple of tougher problems. Working with tangents and cotangents, again, we already saw that you're going to have to do a little bit more work, but notice we also have a couple of negative angles going on here, as well as on the right, a large radian measure. So see if you can work out those challenges. I'll pause the video now and put up the full answers down for you so you can sort of finish those out at the end of the video. Alright, these last two challenging problems are all worked out for you. You'll notice the first thing I did was notice that a negative 120 degree angle, you can either go find that directly, knowing that it's double a 60 degree angle, so you could sort of take those and count your way down, or you can add 360 and find a coterminal, so 240 degree angle. The tangent at 240 and the tangent at negative 120 will have the same values. They're the same coterminal angles. So the points given to you there, again, take the y divided by the x. You'll see the fraction work here. Canceling the 2's, canceling the negatives, and ending up with root 3. The cotangent is the same idea. I went ahead and took the radian measure, adding 2 pi, which remember you need a common denominator in order to add fractions. So I took 2 pi multiplied by 4 on the top and bottom, and you'll notice you end up getting 8 over 4 pi. Well, negative 13 plus 8 is negative 5. If you did that again, you could actually use 3 pi over 4 as well, but I went ahead and graphed out negative 5 pi over 4, putting you at essentially a 135 degree angle, or that 3 pi over 4 on your unit circle. Coordinate points given to you, and again, and actually just notice that I've got an error on there. Notice that y divided by x, remember, is the tangent. The cotangent actually is x divided by y. Now luckily, at a 45 degree angle, they're fairly similar. But if I want to take x divided by y, I need to put my negative value on my first fraction and make the second one back into a positive. But then again, the values are still going to cancel away. When I multiply those two together, cancel the 2's, cancel the root 2's, you're still left with a single negative, and our answer will actually work out still to be negative 1. Hope that helps you with your unit circle, and if you have any questions, make sure you talk to your teachers. Have a great day.